Hi geometry students, welcome to the lesson for 5.4. Not too much new vocabulary, just need to really know what a midsegment is after we're done with this lesson or as we're going through this lesson. And as always, please do this, make sure you use the extra examples in your book for additional help with your homework or classwork. So let's get started with 5.4. We're talking about midsegments and the midsegment theorem in this lesson. So let's first figure out or decide what a midsegment is. What is a midsegment? So it's named pretty well, I think. It's a segment that's kind of in the middle or connects something with the middle of triangles. So a midsegment of a triangle, we use our little symbol for triangle right there. Midsegment of a triangle is just this. It's a segment that connects the midpoints of two sides of a triangle. And then down here we'll do the midsegment theorem itself. So I put this box here because this is pretty important. This is our most important thing for the whole lesson right here. So the midsegment theorem, which I'll abbreviate like that. This is theorem 5.9, 5th chapter, 9th theorem in this chapter. And at this point I want you to get out something to draw straight lines with. So take out a ruler of some sort or a straight edge of some sort. Take that out and let's do that here. I have my tools automatically let me draw straight lines, but I'm going to use this to measure things too. So take out your straight edge of some sort. I'm going to draw a triangle first of all. Let's make this triangle, the actual triangle itself, a little thicker. That'll do. Try to make your triangle look similar to mine here. It could be any old triangle. This does work for any triangle. But if you make it look like mine, then we have something easy to compare. Alright, so there's my triangle. And I'll use a thinner line for some of these other things. Now, to find the midpoints of the two sides, I actually have to measure. So that's what I'm going to do here. I'm going to put mine in centimeters on the top scale. There we go. And so now I just need to measure each side. So this looks to me, let me put that back in millimeters, because that'll be a little more accurate, I think. So let's slide this down just a skosh there. Here's 0. This to me looks like it's about 66 or so. So I'm going to find the midpoint of the side here is at about 33. It is at about 33. I'm going to do the same thing for my other two sides. Your triangle may be a little different than mine in terms of the size, so you use your halfway point. You find the midpoint of each side for yours. It may vary slightly from what I have up here. So this looks like it goes from 0 to about 84 or so right there. So that's going to be half of 80 is 40, half of 2 or 4 is 2, so it's 42. Right about there is my midpoint for that side. And again, yours might not be the same as mine, so you measure yours and you decide what halfway is from what you had, and then I'll measure my final side. So here's 0 to, looks like about 87 to me right there. So half of 80 is 40, and then half of 7 is 3.5. So I'm going to go right about there, go straight up from there and put a point right there. So we are drawing the midpoints of the segments. So we found our triangle, we got our triangle. Now connect those with, or actually this one I didn't actually need, so it's fine that we found that, but I'm going to erase that one. We're just going to do one of these midsegments for now. And so I'm going to draw a straight line here again, make this a little thinner, and connecting the midpoints now of the triangles. I feel like I can make that just a little better. Right there, that's where I want it to, right there. So we want to be pretty precise with this so that everything looks right. And then take out a different color at this point as well. Have that handy. We're not going to use it quite yet, but right here I know that this is congruent to this because that was the midpoint. I know that this segment here is congruent to this segment right here. Same reason that was the midpoint. And then up here, now I'm going to say this would have to be true. The midsegment theorem says that this is also going to be true, that this side and this side are always going to be parallel. So let's over here write down what the midsegment theorem says. The theorem says that we got to give our labels, or our vertices, some labels here first. This is A. We'll call this triangle ABC here, and then we'll call this D and E right here. What it says is that DE, segment DE, is parallel to segment AB. And it also says, if you measure this, let's actually do this. So if I measure this, that looks like about 43 or so. And remember, this one we already measured was about 87. So this, could that be 43.5? Yeah, I would say that's about 43.5 right there. And so you'll notice this one is twice as big as this one. In other words, this one is half as long as this one. So that's what the rest of the part of the theorem says, or the rest of the theorem says. It says that DE would be half of AB. Or in other words, AB would be 2 times DE. That's another way to think of it. So this is the big thing to remember. This works with any midsegment. So if I drew this midsegment from here connecting to the midpoint here, that would be true right here. This one and this one would be parallel. Same thing with this one and this one. They'd be parallel and they'd be half as long, the midsegments themselves. So let's move on to a couple examples, and let's check this out. So I've got Big Joe Williams. He's a famous kind of blues type player. I just listened to him play a little bit, and he sounded pretty cool. I'd never heard of him before, but I looked him up for, you'll see why in the context of this problem. So let me draw this triangle yourself. Let's make this a little thicker to start. This is the original triangle here. And make your triangle look like mine as best you can. Looks good. Okay, so it almost looks isosceles here. I think I want to adjust that a little bit. So let me I want this side to actually be just a tiny bit shorter than my other side. So I'm going to go like this. Okay, so this side to me looks just a skosh smaller than this side, but I want this to be my longest side. So not quite an isosceles triangle, but pretty close. And then I'm going to give some labels to the points. I'm going to call this B, up here I, and down here G, and then find the midpoints of each side. So we're going to take our ruler and make sure you're drawing these lines with a straight edge with a ruler. I want these to be precise drawings, and this is about 83 it looks like here, so that's going to be 41.5 for the midpoint. Right down to about there. Let's measure these other two sides. This one I'm going to put in all the midsegments, so we're going to find the midpoint of all 3 sides. And why don't I pause the video while you do that. Okay, so pause if you need to here, but this was 112, so I got 56 here. This one, I forget what the exact measurement was, but I found the midway point, I found the halfway point there. And now I'm going to connect those midpoints here. All 3 of them, I'm going to connect them all. So I'm going to make this a little thinner. These are my midsegments here. So from here to here is one midsegment. It's the midsegment for this side. And there, and then here and here. Whoa, didn't let go of the pen there. Let's try that again. Okay, almost. That one was my fault. There we go. Okay, so we've got the 3 midsegments. Now let's add what we knew to start. We knew had to be true at the start, so we knew this had to be true because we found the midpoint. This had to be true. We found the midpoint here and here. And then this also had to be true because these were all midpoints. And so what else has to be true? Different color. Take that out at this point. Get out a different color. We know that this side would have to be parallel to this side. put that in a different color for me. And we also know that this is twice as long as this. So if this is twice as long, you've got two segments of equal length here. That means this length and this length would have to be the same. So I could just put 2 tick marks right there. And I could do the same thing with these other sides. So I'm going to use, why don't I go with 2 arrows here. I don't have to do it this way, but I've got 2 tick marks, so I'll just keep these things aligned that way. So 2 arrows here and here. If I did this line, this one here would be parallel to this one here, and I've got this BI is twice as big as this one, so I could put just a 1 there, and then here I've got this side that would have to be parallel to this side down here. I'll add that in using a different color here, and I could also say that this would have to be true, that this length would be half as big as the whole thing together. Okay, and let's give these other points some labels. And here's where Big Joe finally comes in. And so here's a J, O, and E. I said folk, but jazz, yeah, folk jazz kind of player. Played a 9-string guitar, pretty cool. He sounds really cool when he plays it. So let's take a look at some of these things here. Now this one, I measured this, yes, but I'm going to tell you that these things were true to start. I'm going to tell you that JO is 8. So let's put that in the picture. I'm going to tell you that GO is 7. So let's see if we can figure out some other things. And I'm going to also tell you one more thing. BG, the whole thing from there to there is 15, from all the way from here to here. So what if I asked you, what is EJ first of all? What is the length from E to J? Well, we know that it's half as long as this, but we know that this is 7. This would also be 7, so that would be 14, the whole thing. So this has to be half of that. I also know that this segment is the same as this segment. The way I labeled it, that has to be true. It has to be half as long, so it has to match up with from here just to the midpoint. So I hope that's clear to you that that would be 7. So EJ would be 7. What if I asked you for EO? What is EO? We'll box in just the numbers here. What is EO? EO would be, well, this has to be, go back to your theorem if you forgot, it's half as long as the longer segment that is parallel to itself. So the mid segment, half as long as the segment it's parallel to. This has to be half as long as the segment it's parallel to. So what's half of 15? That's basically all we have to do here. 1/2 times 15. Half of 15. You could say 15 halves, but I think the better way to say that would be 7.5 or 7.5. One of those two things. Because you're not going to go up to somebody and say, hey, this is 15 halves long. 15 halves, yeah. They would just be like, huh? Can you tell me what that is as a decimal or a mixed number? So we would write it like that. What is IG? IG is equal to, well, this whole thing from here to here. We already discussed this, but this is 7, this is 7. Twice of 7, 2 times 7 is 14. You'll notice none of these have units up here, so I'm not including units here. If they had units, I would definitely want to include that. And BI, what is BI? Well, this is not given to me either one of these, but I know that this is going to be half as long as this. In other words, I know that BI is going to be twice as long as JO. So I could do 2 times 8, which would be 16. Hopefully this is coming along pretty easy for you. I think it's a pretty easy theorem to understand once you start catching on. And let's say a couple more things. What if we had to find perimeter? Okay, so I'll use that for my abbreviation for perimeter of triangle BIG. Triangle big. Perimeter, what do? We add up the sides. We add up all the sides. So BI, we already know that's 16. But let's write it with the letters first, just so we have the idea of where this is coming from. Big BI plus IG, that's the second side, plus the third side, it's BG. So if we replace all those letters with the numbers we know that they're equal to, this is 16. IG, we figured out, was 14. And then BG, it's right there in the picture, that's 15. You add those three things together, this is going to be 30, plus 15 is going to be 45. And let's do one more thing, this one, the perimeter of Joe. Triangle Joe. that would be in a similar manner as before, JO plus OE plus EJ. And we have those three things added together. What's JO? JO was 8, that's clear from the picture. OE, or EO, we figured that out, was 7.5. We'll use the decimal one here. And EJ was from here. We knew that this and this matched up. We knew that that was 7 right there. So we have 7. We add those three numbers together, and we get, looks like this is going to be 15.5 plus 7 would be 22.5. Okay, so go back and review anything, pause, rewind if you need to catch any of that again. But let's check out what will be our final example for this lesson. This one I want you to draw a careful graph with me to start. So we're going to use our ruler here to draw a nice careful graph. And we really need to go, looks like up 9 and then down at least a couple. So we're going to go, why don't we just go 10 and 5. I've got these markings here from 0 to 150. I'm going to change my scale to centimeters to make it even easier to see. So I'm going to use this. You have centimeters on your ruler. I think this would be the easiest way to go. So let's use this, make it nice and straight. Now I've got my straight edge line, so I'm going to just use those, but you draw a line from 0 all the way to 15 on there. This one's going to be pretty big, so you're going to need plenty of space for this one. This one, there's other ways to do this, but if we draw the picture carefully, this I think is the easiest way to do it. Keep doing that. I want this to be nice and straight. Okay. And so while we're at it, I want to actually make markings here too. So we're going to make some markings here at each centimeter, because we want it to go 10 up and we want it to go 5 down. So I'm going to put little markings here, here, and just keep going with that. I want it to be real precise with this. 7, 6. So you're doing the same thing on yours. If you have graph paper, this would be a lot easier. But if you don't have graph paper, doing what I'm doing here. Come on. Okay, so this would be going up. This would be going down. And this is going to be my axis. So I'm going to make that a little bigger here. And now I'm going to rotate this around. I'm going to get it back to 0 degrees. There we go. And I'm going to do the same sort of thing here. But I want to go now 10 this way, positive direction, 5 this way in the negative direction. Use your straight edge to draw a straight line first of all. And let's put that straight line, we'll line up right with that. And you can go from 0 all the way to 15. Oops. And then we'll draw in our marks, or tick marks for each one. So at each mark, we want this to be real precise. If this picture is not very precise, then our answer will be thrown off. We won't be able to tell what the right answer should be. So we got to be very precise and accurate with this picture. Okay, so here's my x-axis, here's my y-axis. Let's label those real quick. This is x, and this is the y-axis. And I want to start with these points. I want to start with 1, 3. So here's 1, here's 3 going up there. This is going to be point L at 1, 3. And I want to go 3, 7. So here's 3, and then count carefully. Let's label these at least every 5. So 1, 2, 3, 4, 5. This is 5, and this is 1, 2, 3, 4, 5 right here. So let's put that in there. So from there I'm going up 2 more. Here's 3 there. So if I went right up from here up to there, that's 3, 7. That's where I want that. So this is going to be M, 3, 7. And then finally I'm going to draw another point at 7, 3. So here's 7, going up 3. This should be at the same level as L was, going directly across there. So this is going to be point N at 7, 3. And then I want you to use your straight edge to connect these with some straight lines. I'll use my straight line tool to do that here. Connect those, make it look pretty, and connect those with straight lines. Okay, so here's the question. We'll write this up to this, or off to the side here. These are the mid-segments of the triangle. This isn't the original triangle itself. So this big triangle, if these are the mid-segments, we're going to have a triangle that goes around the outside of this. I want to try to find the vertices of that triangle, though. What are those original vertices of the triangle? So let's write this down. Here's the question. The midpoints of the sides of a triangle are, we had L at 1, 3, we had M at 3, 7, and we had N at 7, 3. And what we want to do is find the coordinates. And as you're writing this, we don't want to draw anything beneath a line that would go across here, so try to make sure that's happening as best you can, of the coordinates of the original triangle. Coordinates of the vertices of the original triangle. Okay, so what can we do here? What do we know about the original triangle and the midsegments? We know that they are parallel. The sides have to be parallel, just like they were there. And so this is going to be in our different color again. This was not there to start. This is new stuff now. And so let's draw these lines so that they're parallel. To figure that out, I would need to know what's the slope of each one of these lines. This one's real easy to look at and say, hey, that slope, I hope you can tell, is 0. It's not going up or down at all. But let's work this out down here. So this triangle, I can visually see that it's going to be something like this and something like this, something like this. So I'm going to have some space here to calculate my slopes. So let's do that down here. And we can say the slope ln, let's start with that. And you can do your, remember slope in general. Let's do that over here, slope equals, in case you forgot, y2 minus y1 over x2 minus x1. So we're using that idea. Make that so it doesn't overlap my letters there. There we go. That is true, and so we're just going to use that idea. So if you didn't see that this slope was 0, it is just a horizontal line which always has a slope of 0. We could verify that by plugging these things in. I'm not going to label these things right now, but this you could say is x1, x2, or x1, y1, sorry, and x2, y2 over here. So 3 minus 3, and then 7 minus 1. This would become 0 over 6. 0 divided by anything is 0. So we have one thing that has a slope of 0. One line has a slope of 0. The slope of LM, so we're going to use L and we're going to use M. I'd call this my x2, y2, so 7 minus 3 on the top, and then 3 minus 1 on the bottom. What is the slope of this? This is 4 over 2, which equals 2 over 1, or you can just think of that as 2. And finally, what's the slope of MN? Slope of MN, here's M, here's N. Let's go left to right here, so I'll call this x2, y2 here, 3 minus 7, or y2 minus y1, and then 7 minus 3, or x2 minus x1. So this would be negative 4 over 4, or negative 1. So the slope of each one of these things, now let's draw in the line. So we know that the slope of whatever the line is up here has to have a slope of 0. These are going to be kind of construction lines for us, and we're going to see where they intersect. So this one has a slope of 0. I'll use my horizontal line tool for that. And I'm going to make them a little longer than I really need to have them, because I just want to see where they cross. So I'll do the same thing with yours. This is going to be a little longer. I can tell that this one's going to cross somewhere over here, This one's going to cross somewhere over here, so I went a little longer than I needed to. So this other one has a slope of 2, or in other words 2 over 1. Let's write that in my different color down here. You can think of that as 2 over 1. You can think of this as negative 1 over 1. So put that in a different color right there. And then let's actually plot some points from there. So LM is right here. The side parallel to that is going to be over here. So this one, I should go up 2, boom, boom, 1, 2, and then over 1. I'll put another point there. And I'm going to continue that pattern. 1, 2, over 1. I'm going to have a point, hey, right there. That looks good. That looks like it's where it's supposed to be. And then if I went the other direction, I could go down 2. That would be like negative 2 over negative 1 would be the same thing as positive 2. So I could keep doing that. And down 2, right 1, draw another point. Now let's connect those points with a straight line again. So I'm going to start from up here, go through there. Drawing should be pretty good here. So you notice all those points lie on that line. And then the slope of negative 1. Let's draw those points in. So you're going to go down 1. That's negative 1 over right 1 would be positive 1. Keep that pattern going. Down 1, right 1. Down 1, right 1. Down 1, right 1. We got another point right there. There it is. Okay, so that matched up there. If I went up 1, that would be like a positive 1. I'd have to go left 1, which would be like a negative 1. So up 1, left 1. That also equals negative 1. Up 1, left 1. Okay, and now it looks like all those points fall into place. Let's connect those with a straight line. Notice it's overlapping a little bit. That's okay. That's kind of what I wanted to happen. And they touch right here. What are these points right here? These points are, I'm going to give these labels. I'm going to say that this is point A. This is clearly, I hope it's clear to you, it is 5, negative 1. If you drew your picture right, that should fall into place. So this is still in our different color. Let's make that stand out that way a little bit. I'm going to call this point B. This was at all the way over at 9 and then up to 7. This was at the same vertical level that M was. So this is at 9, 7. This one's also at a Y value of 7. I'm going to call this point A over here. Not A, sorry. I'm going to call this point C. I've already used A. So this is going to be point C. And we'll say that C is at, if we look here, it's 1, 2, 3 back and up 7. So hopefully you noticed why I was careful, or why it mattered to draw careful pictures here, because if we didn't do that, we wouldn't be able to tell where this actually intersected. If you were sloppy with your scale, the picture is going to be off. What can we say had to be true about these lines? I could put this in as well. So let's draw this in here. We know that this and this would be parallel. We know that, here we go, we know that this side and the top would be parallel. And we know that this down here with that would be parallel. So all those sides are parallel. I also know that this is twice as long as this. I know that this is half as long as this. I know that this one's half as long as this one. This one's half as long as that. So all those things match up. You could verify that by actually looking at the points, going from 3 to 9 is 6, negative 3 to 3 is 6, from 1 to 7 is 6. So twice as big. You could do that with the other two sides as well. But right now, that's not what we need to do. We just need to find the vertices, the coordinates of the vertices of the original triangle. So let's write this down. I ran out of room here, so I'm going to write this on another page, but this still goes with that example. So to recap what we just did there, let's write this down. This will finish it up for us for this lesson. Knowing the slopes, or knowing these slopes, we figured out the slopes right here. Knowing these slopes, we can draw in the sides of the triangle parallel to each midsegment. That's what we did. Going back here, that's what we did. We found the slopes and we drew the lines parallel to their particular midsegments. And each intersection is a vertex of the original triangle. What I meant by that was right here, where they crossed, that was a vertex, where they crossed over here, and where they crossed over here. So those three things were vertices of the original triangle and the coordinates of the original triangle are what we figured them out to be in the picture. You had A, just went with A, B, and C. So A was at 5, -1, B was at 9, 7, and C was at -3, 7. And so that'll do it for this lesson, for the notes for this lesson. Let me know if you have any questions in class. Thanks.